Welcome back to the second video on the restoration of this Bosch VHF64 tube radio. As I mentioned before, this is the first British set that I'm doing, and there are a few surprises in there for me due to lack of experience and nothing else. My experience has been with German sets, so this is the first for me in terms of restoration. And the differences are pretty obvious, both in structure and in the actual parts of the circuitry. So it's actually a little bit more interesting now because you learn as you go along. Anyway, it's out of the chassis. I put it in my contraption to make it easy to move around when I did the restoration. The ferrite antenna, which I had intended to desolder from this terminal block, has stayed in circuit for the simple reason that it's an integral part of the AM circuit. So if I did remove it from here, I wouldn't have these coils in circuit when I finally tested the radio function. So I left it in and just taped it to this support here to be able to leave it in the radio as I do the restoration. And it doesn't get in the way as it is. The speaker, they were very easy to get out because they'd literally unscrewed from these three connectors. These two are for the main speakers, and this one here was using the ground, common ground, was for the electrostatic tweeter. So those came out quite easily. I wired in my socket and taped it to here so that I can use this connector that I have connected to a spare speaker. This way I don't have to lug the cabinet around when I want to test the function. And so this then was ready to move on. And moving on meant checking the power supply. That's usually the first thing that I do, is make sure that the two transformers are working. And this one was tested by removing the EZ81 rectifier tube and checking for any shorts before connecting it to the power, which I did. It has a selector here for 110, 210, 230 and 250. It's on 230. I'm leaving it on 230 for now. We'll check the voltages later. When I did test it, I got 330 or 340 volts out here. Bear in mind that because this is using the EZ81 rectifier tube, this is a center tapped output transformer, which means it is something like 250 volts, 250 volts. So you literally have 500 volts across the ends there. And when it goes into the two diode connectors here, you're getting a full wave rectifier. So you have to be very, very careful when you play around with this. There is 500 volts coming out of this thing if you touch it across the two ends of the secondary. To ground, the center tap of the output is connected to the chassis. So from ground to either one of those two, you have about 250, 240 volts AC coming out. So that was shown to be working because I measured the voltage, the two voltages coming in there. And so then I wanted to test the output transformer. And the way I did that was to connect a signal generator with about 1 volt peak to peak 500 hertz sine wave, just an audio tone, across the primary. And the primary of this transformer is the output or the anode of the EL84 output tube and one of the B plus connectors. So that was pretty easy to come by, and the result was I got a tone coming out of the speaker, which was good. So this transformer is fine, that transformer is fine, it's a go. Not that it wouldn't be otherwise, but it certainly makes life a hell of a lot easier when your main components are working. So the next step was to try and get some of the grime off, and as you can see, quite a bit has been done. The dust was removed, and quite a lot of isopropyl alcohol was used just to clean up all the metal, all the surfaces. It's now a hell of a lot better than it was before. And once you've cleaned that, you can actually get a better view of what you're working with, because some of these components were literally invisible. As you can see, it's a heck of a lot better. This gear mechanism for the tuning condenser and the FM tuning has all been cleaned up, and some of the cogs have been oiled. So it's looking a lot better and working a lot better. And as I suspected, the chassis doesn't really have any rust, which is a good thing. There was a lot of dust, but once you clean that down, very, very little rust, except on some of the little screws. Some of them are a little rusty, but those are easy to clean up. So the chassis is actually in very, very good shape. So having determined that these two main components were working, there's the power transformer and the output transformer, I started my usual testing and coloring in. Let me show you or tell you what I've done so far. Your AC power comes in, it goes through a switch, both phases are switched off. That's working. So power gets to the transformer. The output of the transformer, there's the heater voltage, the heater winding, and that was tested at 6.5, 6.4 volts AC, which is about fine, just a little bit high. But again, there was very little current being drawn by the rest of the circuit, so I expect it to be a little higher. Both lamps were working, so they've got painted in. The heater voltages, I then checked all the pins on the tubes to ensure that they were receiving the correct heater voltages, and they were indeed receiving the heater voltages. So the heater voltages are fine. Then the output comes out of the EZ81 to the first filter capacitor. That filter capacitor is a can with 3 sections, 40 microfarad, there's the other section, another 40 microfarad, and there's the other section, 20 microfarad. Now when I tested them, they were about 46, 46, 24, which isn't too bad, but I measured the leakage, and there was about 3 milliamps of leakage at 350 volts. So I dropped the voltage down and just reformed them slowly, bringing up the voltage. And after about a couple of hours on each section, I've now got these leakages to acceptable levels of about 400 microamps. So that's fine for this, this value of capacitor and this operating voltage. So that was fine. Obviously doing this gives you quite a bit of time, so you start checking other things. And the other things that are checked are resistors. They get painted in. All these resistors that you see here are painted in. There's one resistor here that doesn't appear in the radio, although it is in the circuit. So that was just left, that's just a short. That resistor doesn't appear either. And then I went on checking stuff. And what I found was that every capacitor that I came across, or most of the capacitors that I came across, like those paper caps, are all completely buggered. Very leaky, values completely off the charts, so they were all replaced. There's one here from the B plus that goes down to the anode of the EL84. That thing was leaking like crazy, and I can just imagine the damage that could have done, and probably did do, because here's the next problem that I found. While I was on this section, I decided to do the checking of the bias arrangement here, and I found some strange things. Okay, these resistors were fine, but here, that resistor, that's the cathode resistor, that was fine, it's within spec. But this capacitor, this is the cathode bypass electrolytic capacitor, which is a 50 microfarad, 15 volts, was a complete dead short, literally a dead short. So that did quite a bit of damage, I'm sure, to the way this thing was operating. Here it is. When you measure like 2 ohms or 1 ohm across this. So this one was completely dead. So that was replaced. Now, why that was dead is a bit strange. But when I went and looked at it, there was something else that I found here, which was a little bit unusual. And that was, I found another connection from the B plus. From there, B plus, there's a resistor, a capacitor, which then goes to the cathode of the EL84. So if I draw it here, just to get this out of the way, there's a connection from here, which then goes through a resistor, a capacitor, and then comes and joins this guy over here. Now that's very, very strange. I thought this was an error of sorts, but then I'll tell you what I came up with. This is a 0.2 microfarad, and this was measuring 680 ohms. And that I found very unusual, because what you're literally doing is you're putting a direct AC connection between the high voltage over there and what should be 7-8 volts down here, DC. The other thing you're doing is you're putting a connection from this point where it's very, it's probably got quite a bit of ripple. It's just at the first capacitor. You're putting that with ripple into your cathode of the EL84. Now, this thing had me completely stumbled, because first of all, I found this guy was leaking. This thing was leaking really badly. So that explains why this thing died. If this thing is leaking and you've got a low resistor here, you don't have DC coming through, but you've got quite a bit of ripple coming up. And there's nothing to say that this ripple won't be high enough that when you add it to the DC voltage over here, you don't exceed your capacitor rating, which is probably exactly what happened, and that's why it shorted. This thing was leaking current, DC current, which just made it worse, because the more current, DC current, that went through here, the higher this DC voltage went. So this thing was probably around 15-20 volts on a 15 volt capacitor. So this capacitor died. What this meant was that if you are increasing this voltage over here, the DC voltage, due to that leakage, this is just looking at the DC operation, it means that this tube would cut off. You'd have very little sound coming through because it's literally cut off. So that's the first problem. The second problem was this resistor looks very, very damaged, burnt, and I couldn't actually see the value on the resistor because it's dark. It's measuring a resistance value which sounded or looks like it's standard, but it's had a hard life, which means that this could perhaps not have been the actual value, and I'll come to that in a second. So this capacitor was changed, but I still couldn't figure out what this is all about. And then going and checking some forums, I've discovered what the idea is. The idea is that you are feeding the ripple or part of the ripple voltage onto the cathode of the output tube. This same cathode is seeing the ripple voltage that comes from here, there, through that transformer. The output transformer then goes to the anode. So you've got a ripple over here which would normally be amplified, and you would see it or hear it across the speakers. So what they've done is, instead of putting more filtering up here, which you could do with a choke or a bigger capacitor, or as they use on some of the German sets, a anti-hum winding on the transformer, which is effectively another inductor that you put in the line, they decided to feed the reverse phase of that ripple, which doesn't only come out here, it comes from the previous sections as well and gets amplified. They decided to feed a reverse phase of that ripple by taking it directly from here onto the cathode. So the idea is that if you have hum over here, if you've got ripple over here and you've got the reverse of it over here, when it does its amplification, it literally cancels out. So this was a hum cancellation modification which they implemented to try and reduce the hum on these radios. And there is documentation on it. In fact, in the schematic that I have, or rather in the service manual that I have, one of the pages says that previous versions of this set had an anti-hum, did not have a hum reduction coil on the transformer, which is what you see there, and actually had this circuit, and they describe it as 0.2 microfarads and 6.8 kilo ohms. So this thing was at 1/10 its rated value. So this guy is definitely burnt out, basically, almost shorted out. So you can just imagine the effect of having 300 volts coming through here, leaking through there, very little resistance here to drop it, and the effect it would have on this voltage is, well, mind-boggling. Not nice. So this has obviously seen quite a tough life, and what I did was I then checked these components, I replaced that, I left that in place, but I replaced these two components. Actually, this one I haven't done yet. It's still there, and I'll show you. And then I went checking through the power supply line of the radio all the way through. And basically, most of the components on this power supply line are fine, except for a couple of capacitors, which I've already changed, like this coupling capacitor. This is the main coupling capacitor that will end up sending your signal from here, from the preamp stage, goes through there, through a tone control. Through here, there's another tone control. This is a treble bleed into the base, or rather into the grid of the output tube. So if you have leakage on that capacitor, which we did have, I checked the capacitor, it's very leaky. This would also affect the DC bias of that point. So this tube, I'm not sure if it's working, because it's seen a hell of a, it's had a hammering. It's had a hammering from the grid voltage over here, which would have been very positive rather than negative probably. And then you've had this thing going up. So I don't really know what the hell happened here and whether this tube is actually working, but we'll find out soon enough. Continuing with the power supply checks. Again, everything was checked to where it's supposed to go. The resistors in line were more or less within spec. Nothing like the ones that I've found on some of the German radios. These guys were a little bit high, but not high enough to raise any alarms. So the next thing I want to do is I want to show you the component changes, which I've shown here, but I want to show you on the radio itself. And then I want to actually power this up today and see if we've got any reception whatsoever. The underside has also seen a bit of cleaning. There wasn't much to do, but some of the dust was blown out and some of the more grimy parts were cleaned out. But as you can see, there's not much that has changed here. These two capacitors were changed. The one of them is that hum reduction circuit, the 0.2 microfarad. And the other one here is that coupling capacitor that I showed you. So those were changed simply because this board got removed, got cleaned, the resistors here got checked, and I was able to then put it back. The resistor that I mentioned in the hum reduction circuit is that guy over there, that one, which I now need to change because I've discovered it should be 10 times the value that I'm reading over there. And as you can see, you can hardly tell the value, it's just blacked out. That there is that cathode bypass capacitor that was replaced. That's the one that was shorted. So that was wrapped in tubing and connected in place. Other than that, nothing else has been done except some of the checking. So I think we're ready for a controlled power up of this guy. See if it's got any life. I think it's been checked as much as it can be for safety. I don't have any shorts around there. So let me set this up. Let's connect it. So I've got the dimmer on, active. All these are off. One lamp is on. The radio buttons are off. So I'm going to give it some power here. Okay, 233 volts is my line voltage. And what I'm going to do now is switch on my, I'm going to try a medium wave. Let's watch that light bulb. 1, 2, 3. Okay, the lights come on. It's reading 120, 100 milliamps. Okay, no shorts. The lights, the panel lights have come on pretty dimly. Got the volume fairly low. Don't hear anything, but let me give it one more light bulb since we've got no shorts. Right, so we've got 206 volts going in at 150 milliamps. Still not hearing anything. Let me try the volume control. Just a very, very low hum. Let me try an antenna over here. Let's just connect that. Oh yeah, okay, good. We've got some noise. Right, we've got very dim, very low. I'll give it another light bulb. It's drawing 170 milliamps. Volume is on maximum. Don't hear anything except noise. Try shortwave. That's expected from my router, but brilliant. We've got something. Very low, but we've got something there. Let me try FM. Picking up something. Let me give it another light bulb. It would help if I had some sort of antenna on here. That's a bit more lively. It's very odd for FM. It's picking up something. Whoa, really distorted. All right, let's put that off so we don't cause any damage. What have we got? We've got sound. We're picking up some of the AMs very badly. We're picking up FM very distorted and pretty poor reception. AM is very low. FM seems to be quite loud but very, very unclear. So this thing is not completely dead, which is a good sign. First thing I'm going to do is swap some of the tubes around, check some voltages, and if the tubes are fine, then it'll be a capacitor problem, I think, or an open resistor somewhere. But anyway, that's good. We've got something. We've got some life. Bye for now.